Hello there. If you are a GMAT aspirant and right now you're wondering whether this video is for you, give me 10 seconds and I'll tell you what you'll get out of it. Well, this is a 5-minute investment right now, which will equip you with a foolproof approach, one step-by-step approach we're going to give you that will help you solve all questions testing the concept of correlation asked in the form of table analysis questions in the DI section, Data Insights section of the new GMAT Focus edition. This is a very, very important concept, and the way that it is tested on table analysis requires you to have specific time saving strategies. Otherwise, you will be lost in these questions and waste precious time, where actually table analysis is supposed to give you time saving opportunities. And how are we going to do this? We will do this by discussing a hard question, 645 plus level on the GFE. This is a question that only 45% of all students who've tried have gotten this correct. So 55% people who did this got it wrong. Through this hard question, we are going to build this approach which will set you forever for all these questions. Does it sound like a good deal? I'm sure it does. Let's join in. Before we go deep into the approach, I'm going to give you a quick review of correlation. If you feel you're totally comfortable with this, you can skip to the next part in the video. So, quick review. What is correlation? Correlation measures the relationship between two variables. Now, whenever you have two variables, you want to see how changing one is corresponding with the change in another. There are three types of correlation that you have to understand: positive correlation, negative, and no correlation. Positive correlation shows that the two variables move in the same direction. They could both be increasing or both decreasing. Negative correlation shows movement in opposite direction, as you see here. One increases, the other decreases. While no correlation is when there is no predictable pattern between the variables. You can't really tell what's happening when one of them is increasing. Is the other one increasing or decreasing? It'll seem to be going everywhere. It'll be just scattered. That is no correlation. Okay, quick review done. Now, you want to really infer correlation from data presented to you in the form of a table. While a line chart is very easy to read, if you see something like this is where it's going upward. It's an upward sloping chart, which shows there is positive correlation. While if it's coming downward, it shows negative correlation, and obviously, no correlation will be points just going everywhere. Here now, when it comes in the form of a table, when your data is not plotted like this, which makes reading so easy, we developed a method, a step by step process in the video that I'm linking up for you. Go check that out if you haven't seen it. Now, the summary of that method is here presented to you. You will identify which data sets, first of all, you're looking at, between which you want to check correlation. After that, you'll sort one column, which corresponds to one data set. Then, based on this sorted one column, the other one, which will still be unsorted, you split it into two parts, an upper part and a lower part, and then you infer the correlation. You see whether values are getting larger as you go down, or are they becoming smaller, or is there just about anything happening. That'll tell you what kind of correlation there is. Now, this video, we will build upon this process and we will add another tool to our arsenal, which will make this inference even more easy. So we're fine tuning the process now in this video. And we will do that through an official question, which is right here in front of you. Before I talk further about this, just pause the video and try your hand at this official question. Remember, this is the one that has only 45% accuracy. 55% people who attempt it got it wrong. But don't worry, pause, give it a shot. Done? How was it? How did you feel doing it? Well, I'm sure you at least realized that out of all of the statements, the one of interest to us, the one connected with correlation, was statement 2. So this here now is only statement 2 and the entire information we had. Let's just quickly go over the things that were given to us. We had a table. There were several categories, about 9 stores in a small grocery chain. These are the stores A through I. And then we had self-check express lanes and unlimited lanes, different lanes that we had there. Then whether there was a pharmacy there, whether fuel was something that you could get there, whether there was a restaurant there, and average customer age that visited the particular store. And then we also had an average row for some of these columns. Obviously, it doesn't make sense to have an average yes or a no for whether there is a pharmacy or so on. That's why there are these blanks here, and you only have averages for these two columns, the first two, where it's actually numbers you're talking about. And for the last one, of course, again, numbers. We were talking about age. Now, understanding this data set obviously is the first step. Now, see, in this particular question, they are talking about in the statement is talking about negative correlation between number of self check unlimited lanes and average customer age. So it's these two things between which we have to judge correlation. So your first job should be to find out which these are. Let me just actually take away all of the text from here so we can only and only focus on the main part, the meat of it. So number of self check unlimited lanes, number one, average customer age, number two. Where is it now in my table? That is my first step. First step is to get what you need from this huge mass of data. So you will first of all identify the two data sets between which you want correlation. And again, remember, when you're trying to talk about relationship between two variables, you have to have two variables. There have to be two distinct data sets. Now, this characteristic of correlation, this is what makes it different from other statistical measures like, mean or median, where you only need a single data set. So this is why this first step should come very naturally to you, that I'm talking about correlation. There have to be two data sets. Let me find those. Okay. So that's our first task here. Now, we will try to find which columns here in the table make sense and are actually talking about the two quantities that we just highlighted in our statement. This is what we want to find out. Now, in this case, first thing is number of self-check unlimited lanes. When I go through all of the column headers, I find that here. Now, when people are reading it in a rush and they don't really own the data set, they're not really immersed, you might just end up seeing the first and the last words and feel that, okay, I found it. For example, self check unlimited lanes, and there's another one, self check express lanes. If you don't read everything carefully under that time pressure, that feeling of rush, you will choose the wrong column. So be very, very careful here. It's easy, yes, but there still is that chance of making mistakes. What's the second thing? Average customer age. Okay, that is easily identified here as the last column. This is your first step, identifying the two data sets. Now, what's your next step? Well, your next step is to sort one of the columns. So, sort one data set basically. Now, actually, we can sort any of them. It could be the first column or the second column. But this is where I'm going to give you a very, very important pointer. Remember, TA questions offer us the opportunity to save on time. This is the time we will have to utilize for more time consuming questions like questions on MSR. Now, between these two columns, make that decision what will make it easier for you to further use the process, take the next steps and infer correlation ultimately. Between these two columns, I will sort by average customer age, this second column. Why? Because the first one here, the self-check unlimited lanes, this has simpler numbers that I can observe to see whether it's increasing, decreasing. But average customer age, these numbers are not very beautiful to look at. These are difficult. There are decimals, you have 4 digits, including the decimal digits. So reading patterns on this would be hard. Best would be to sort these values, which will make it very clear. Obviously, since I've sorted, I have the smaller values up top and the greater values down below. And then observing this one would be straightforward. So basic principle is you sort by the column that was harder to analyze numbers, so that you don't have to analyze for that one, that already gets sorted. And then the easier one is what you end up using for all of that analysis. Then you'll be able to draw your inferences in an easier way. So here I'm adding a little something to the second step. Till now, sort any one column was where we left it. Now I'm saying sort the one with more complicated values. So this way, you don't take the heavy task on you to make sense of these numbers. Let the system sort it out for you, then you work on the easier one. Now, let's get on a cleaner slate and focus on these two. Perfect. Here we are, well organized. We sorted by the average customer age. Now the values are sorted. So you have the smallest value here on top and the greatest value here down below. And the other one, the self-check unlimited links, which has the easier values. This is the one which we will use for our observation. Now, what is the next step? Next step is to observe directionality of the other data set. The other one, basically the unsorted one. Now, again, we made all of the decision. I'm repeating so that this observation that I'm talking about is easier of the unsorted data set. Now, when we really look at that, what do we observe? Should I look at every single data point in this self check unlimited column? No. Again, remember the approach we built. We split this entire set, all of the values in this column into two halves, which is where you make the cut right in the middle approximately. Oh, but I observed something. There is something called averages here. It's a new row. And this new tool at our disposal is going to make this observation easier. Look, observe this average row closely, like this. And this is the average value for our interested column. Instead of splitting the table into two halves like we did, we will now use this average row as the boundary for comparison. Let's see how this average row can be used for this basis of comparison and then ultimately to decide the directionality of the data set. If the values above the average, as you see here, all of these values here are greater than the average, greater than average, and the values below these four here, except the four, they're mostly less than the average. What does this mean? This means that in this column, I have greater values on top. So let's write the big section is on top and the small section is down below in the column. It's the average that I used to make this inference in an easier way. Now, if it's going from big to small, then that means as I'm coming down in this column, in the self check unlimited lanes, then this is a descending list. That means values go from big to small. When I sorted the average customer age, that came in ascending order, smallest to greatest. What does that show you? It shows that as I'm coming down in this list, row by row, these two columns are both moving in opposite directions. One is becoming smaller as you go, the other one is becoming greater as you go. What does that mean? That simply means negative correlation is the relationship between these two. Now, what would happen if we had the flip side? For example, just focus. Okay, that's not the situation here right now. Just suppose that the values above the average were smaller than it, less than average, while the values below were greater than average. Then that would mean as you're coming down, the values are increasing. That would make it ascending order. In that case, both of the columns would be increasing as you're coming down, same direction. That would mean positive correlation. Similarly, another could have been that values above the average in the table and below the average, they are mixed. I mean, some of them are greater, some of them are smaller. There's no discernible trend for the values above the average and below. In that case, you would say it's no correlation. That's it. And now that I know this one is negative correlation, I'll just make another point here. Do not look for perfection in your data. There can be inconsistencies. For example, all of the values above the average were greater. But the values below the average in the table, there was this exception we talked about, no, the 4. Do not let this 4 decide that no, 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 the section below average is also not smaller values. One value here and there, two values here and there will not matter. Your focus has to be on the overall trend. And imperfection is absolutely acceptable when you're considering correlation. In the real world, inconsistencies are the name of the game. That's very, very natural. So, this is how we prove, we show these inconsistencies to you, how commonly they exist in most real world scenarios. It's all explained in detail in our correlation module. For example, if you look at this particular example, we were talking about exercise duration and muscle glycogen levels, and see how very nicely the chart has been drawn here, which clearly shows you this negative correlation with focus on the inconsistencies. It's not always coming down. You see, this place it went up, then it went up here, went up here. Inconsistencies are okay, but zoom out, look at the big picture, you will clearly be able to see how it's all coming down. This is the difference between focusing on the overall trend and just fixating on single points here and there. See how the single points are not really making a difference to us. Okay, now finally, let's summarize our learnings. So, what did we really do in this video? We had this process earlier, and now we fine tuned the process that we learned in the previous video, again linked up for you, by utilizing multiple opportunities presented by the new data set. For example, in this official question, we had the average row, for example. Now, we did this fine tuning on two steps, these two steps. This is where we thought more and made life easy. What happened at step 2 when we were sorting? Remember, you do not randomly sort with any one column now on. You see which column has harder to read numbers. Like, you had decimals here. I'll just quickly show that to you. These are the values we had here for one of the columns. This is the one then we decided to sort, which then allows us to analyze the column that has the easier to read numbers. Then the next level of sorting happened here at step number 3 when we were observing directionality of the unsorted column. Typically, what we did in previous videos was that we have all of these values, just split them into half, like here, read half of the values here above it and half of the values below it. So we had a top half and we had a bottom half. This is what we did, and we used to compare the magnitude of the two halves. But this time we had another tool, the average row, and see how that really saved time and helped us compare very, very quickly. So look at this one first. There is one column we sorted. This is your sorted column. And obviously, because of the way the system sorts it, you always have it in increasing order, the smaller values on top and the greater values down below. So for its own average, also for the sorted column, the values above will be less than the average and the values below will be greater than the average. Now, if for the unsorted column also the same thing happens, this also means that your values are increasing as you go down. And so, since the direction is the same, increase and increase, this is positive correlation. That's it. Similarly, if I talk about negative correlation now, just focus on this. Nothing changes about the sorted column, by the way. That will always be arranged in ascending order. So this will always have this pattern. But for the unsorted column this time, look what's happening. The values above the average row are greater than average, while those below are less, which means as I'm coming down this way, the values are decreasing, which means negative correlation. And finally, let's also look at the last case, sorted column, nothing changes, you are going like this, increasing. Unsorted, above the average, you will have values that are greater than average, values that are less than average, mixed. Below the average also, you have mixed values, no clear pattern. And this is why there is no correlation between the two variables you were trying to judge. As you practice DI questions, be on the lookout for such time saving techniques. Analyzing data is a very rewarding experience and make the most of it as you prepare for DI. This is your chance to invest in building this life skill. I hope you had fun here. Stay tuned for more. Happy learning.